Hello, I'm Paul Jordan and I'm one of the computer science lecturers here at Calworth College. So if you're watching this, then I assume you are interested in taking the computer science A-level. And if you do, I think that will be an excellent decision. In today's fast-changing world, knowledge in computing is even more important than ever. And computing can be used in anything from various computing fields, such as software development, to so many other areas as well, such as biology, physics, maths, just to name a few. So in this video, I'll give a quick overview of the subject so you can see if it's right for you. So the qualification consists of three different components. The first two components are exam-based, and the final component is coursework-based. It's 80% exam and 20% coursework. So the first exam is component 1, which is programming and systems development. The second exam is computer architecture, data, communication and applications. And then finally, the coursework is a programmed solution to a problem. So let's go through each component in a little bit more detail. So component 1 starts with data structures. So that's looking at arrays and records, which you might be familiar with if you've taken the GCSE. And then it goes on to more complex data structures such as stacks, queues, and trees. You've got logical operations, which is your standard and or not, XOR, NAND, NOR, that sort of thing. And then also some simplifying Boolean expressions, which uses some mathematics. Then you have algorithms and programming. So this is looking at the standard algorithms that you might find for searching and sorting and also finding the shortest path and how to work out what is the most efficient algorithm to use in a given scenario. You have the principles of programming, looking at the different types of programming paradigms. So looking at your procedural languages, object-oriented, that sort of thing, and also how then to best display those languages. You then have systems analysis. So this is looking at how you can create or how you can take a piece of software from the idea phase into reality. So it's looking at different project management approaches, so in particular waterfall and agile. Then you go through a series of tests for feasibility. You investigate whether it's appropriate or not. There's a bit of changeover where you change over the old software to the new software. There's some testing, you have to do some maintenance. We look at backup and recovery, and then finally how to document it. There's systems design, looking at human-computer interaction, so the best interface to use, and then we can evaluate those interfaces and decide why certain input methods might be better than others. There is software engineering, looking at the integrated development environment program construction. So this is taking in the code that you have written into the IDE and translating it into a language that the computer can understand, the ones and zeros, and how exactly it does that. And then finally, moral, economic, legal, ethical, and cultural issues relating to computer science. So for this, we have a look at the computing news and see how everything is applied to real life scenarios and the effect of those. In component 2, we look at hardware and communication. So we'll look at the role of the processor, how it works, and also having a look at some assembly language as well, so how it is coded. We look at data transmission. So this is essentially how computers can actually communicate with each other, how they can transfer data between themselves through networks and the internet and things like that. We look at data representation and data types, so how you can actually represent the data on a computer system. We'll look at the different binary notations. We have the organization and structure of data, looking at how data can be stored effectively and organized on a computer system. We'll look at how computers can use databases to structure and organize data. We will look at the operating system and the different types of operating system and exactly how it works. The needs for different types of software and their attributes. So looking at some complex software such as expert systems, which is essentially artificial intelligence. We'll look at control systems and industrial, technical, and scientific systems as well. And then finally, we'll look at data security and integrity processes. So how we can keep our data safe and how we can plan for any disasters. So they are the two exam components, and the final component, program solution to a problem, is the coursework. So for this, you will have your own client and you will be creating some bespoke software for that client. So you will look into what their current system is, you'll fully investigate it, you'll then design your own system, create a prototype, refine that prototype using feedback, actually implement it, actually code it, test it, and then finally evaluate it. Most students use Visual Basic for this, and we teach Visual Basic in college. However, you can also use C#, but ultimately you can use any programming language you like. So it's quite nice, you can be as creative as you like. So after doing the computer science A-level, people either progress into university, apprenticeships, or employment. It links really, really well with lots of other A-level subjects. The classic trilogy is maths and physics, but in reality, it can be combined with almost any other subject because computers are just so widely used. But taking this subject will give you the skills needed to program and also to take a complex problem and break it down to create a solution. And those computational thinking skills can be used in pretty much any career environment. So I hope that helps. If you have any questions, please feel free to email inquiry@calywith.ac.uk. And to apply, you can go to calywith.ac.uk/how to apply, where you can download and email an application form. And I look forward to seeing you in September.